welcome. In this video, we're going to go through a sample paper where we're going to cover the concepts of logarithms, indices, quadratic equations, binomial expansion, and some simultaneous equations. So the first question that we have is solve the following simultaneous equations by substitution method. So we have two equations. The first one is 3x plus y, and the other one is 2x minus 3y is equal to negative 5. So we can name these equations. We call this equation 1, then we call this equation 2. So we can say that from the first equation, that is from equation 1, we can express y in terms of x. So we can say that we have y is equal to 9 minus 3x, you move it to the right, it becomes negative. Then now what we have is what we substitute into the second equation, that is equation 2. So we write equation 2, but this time we represent y with x using this expression here. So we're going to have 2x minus 3y, and remember y is 9 minus 3x. So we write 9 minus 3x, and that's equal to negative 5 according to equation 2. So let us simplify this. You're going to have 2x minus 3 times 9, that is 27, plus 9x is equal to negative 5. So we collect like terms. We have 2x plus 9x, that is 11x. Then we move negative 27 to the right, it becomes positive. So we have minus 5 plus 27, which gives you 22. So for us to get x, we divide both sides by 11. So that x is equal to 2. So now that we have x, we can now obtain the value of y. Remember, the value of y is given by this equation, 9 minus 3x. So y is equal to 9 minus 3x, but we now have the value of x as 2. So it means y will be equal to 9 minus 3 times 2. So that is 9 minus 6, which is just equal to 3. So what we have here now is that x is equal to 2 and y is equal to 3. So let us now move on to the next question in this paper. So the next question is about binomial expansion. You are required to expand, that is 2x plus y raised to power 5. So let us look at that. So the first thing you're going to need are the coefficients of the expansions that we expect to have. So we use the Pascal's triangle to obtain these coefficients. So we just generate the Pascal's triangle up to n plus 1. N in this case is 5, plus 1 will be 6. So we look at row number 6. So the first one, when the power of the binomial is 0, we have a coefficient of 1, and then we have 1 and 1. Then we say 1 plus 1, that is 2, then 1 and 1. Then 1 plus 2 is 3, 2 plus 1 is 3. Then you have 1 and 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and we have 1 and 1. Then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. Then we add 1 and 1. So we have 1, 2, 3, 4, 5, and 6. So this one here is the row that we're going to use in our expansion. So the next thing is just to list what we have. So we start with the coefficients. So the coefficients are as follows. We have 1, we have 5, we have 10, 10, 5, and 1. So the next thing will be to observe how the powers of A in this case is 2x, how the power changes across. the expansion. So we have 2x. So at first, a will always have the entire n as the power, that is 5, and it reduces up to 0. So we have 2x power 4, and then 2x power 3, then 2x power 2, then we have 2x power 1 up to 2x power 0. So it is advisable to simplify this. So we have 2 power 5, that is the same as 32. Then we have x power 5, then that is 16, then x power 4, this is 8, x power 3, this is 4, x power 2, this is 2x, and this is just 1. Then the next thing would be to observe how the powers of b, y in this case, how the powers of y change across the expansion. So we'll have y, then y will always start from the power 0 to n. So we have y power 0, y power 1, y power 2, y power 3, y power 4, up to y power 5. So the next thing would be to just multiply these down. So we have 1 times 32 times 1. So that is just 32x power 5. Then we add with the next, that is 5 times 16 x power 4 times y power 1. That is going to be 80. That is 80. And you have x power 4 and you have y power 1. Then the next is 10 times 8. That is also 80. And we have x power 3 and y power 2. Then we have the next 10 times 4. That is 40. And we have x power 2 and y power 3. Then we have 5 times 2. That is 10. So that is 10x and y power 4. Then finally, we have 1 times y power 5. So that is the expansion for this binomial. But now you are required to use this expansion to evaluate this numerical, that is 2.02 power 5. So what you're going to do, you're going to rewrite that numerical as a binomial, that is, as a sum of two numbers. So, and then you're going to compare their values, their corresponding values. So what you have is 2x plus y, and it is raised to power 5. So I'm going to equate these and compare it with the binomial form of this numerical. So there are different ways you can write 2.02. One of the ways being 2 plus 0.2, and it's raised to power 5. So this way you are able to compare the different parts A with A. So that is 2x being equal to 2, meaning that x is 1. And you can also see that y corresponds to 0.02. So this is 0.02. Let us just correct this bit. It is 0.02. So you can see that y is equal to 0.02. So the next thing would be to use this expansion to solve for this numerical by just keying in those values, the respective values of x and y in that expansion. So we'll have 32 into x power 5, and x, remember x is 1, so x power 5 plus 80 into x power 4, that is 1 power 4, and y power 1, so y is 0.02, then plus 80 into x power 3, that is 1 raised power 3, and then y, which is 0.02, is raised power 2, plus 40 into x power 2, that is 1 power 2, and y is now power 3. plus 10 into 1 into 0.02 power 4 plus, now we have y power 5, that is 0.02 raised to power 5. So now we're just going to obtain these values. So the first part is 32 times 1, which is just 32, plus the next one is 80 times 1 times 0.02. That should give you 1.6. 1.6. The next is 80 times 1 times 0.02 squared. That should give you 0.032. 0.032. The next one is 40 times 1 times 0.02 raised to power 5, which should be 0.00032. The next one is 10 times 0.02 raised to power 4. So when it is raised to power 4, that is going to be 0.0000016 plus the next, which is just 0.02 raised to power 5. That should be 0. And those are several zeros. That is 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Then you have 3, 2 at the end there. So if you sum all of this, you're supposed to get 33.632 16032 as the value of the numerical that we are supposed to find its value, this one here. So you can confirm by just keying that directly into the calculators and see if you get that value. If they're the same, then you're okay. Then part C, solve the equation 1 plus log to base 5 of x is equal to log to base 5 of 12. So we're just going to apply the laws of a logarithm for this case. So the first case is we have to make sure that we are only dealing with logs. So there's a number here which we have to write in log form. And what are we going to do? We're going to use one of the laws that says that if the base and the number are the same, then that log is equal to 1. So we are going to rewrite this equation. So instead of having 1, we are going to have log to base 5 of 5. So we're going to have log to base 5 of 5 now plus log to base 5 of x is equal to log to base 5 of 12. Then the next is just to use the first law of logarithms on the left hand side of this equation. Remember, log to base a of b plus log to base a of c is the same as log to base a of bc, meaning if you have a sum of logs, then that is the same as the log of the product of the numbers involved. So we can apply that to the left hand side of this equation so that we have log to base 5 of 5 times x is equal to log to base 5 of 12. Now we have the log of a number this side being the same as the log of the number this other side to mean that these two numbers are equal. So we have 5 times x, that is 5x being equal to 12. So to obtain x alone, just divide both sides by 5 so that by 5, sorry, we should divide this by 5, not by x. So you're going to have x being equal to 12 over 5, which you can simplify to be 2.4 as the solution to that particular logarithm equation. So let us move on to the next question, that is part D. So we are required to solve the following quadratic equation by factorization method. So for factorization, we are going to look for two numbers whose sum is the same as b. b in this case is -5. So the sum of those two numbers should be the same as b, that is -5. And the product of these two numbers should be the same as 2 times -3, that is -6. So you'll find that these two numbers are -6 and +1. -6 and +1. You multiply these two, you get -6. You add them, you get -5. So after that, you're going to split b, that is -5, into -6 and +1. So we write the equation as 2x squared minus 6x plus x minus 3 is equal to 0. So the common factor between these two is 2x. So we have 2x into x, then 2x into 6x 3 times. So we expect to have x minus 3 this side. But look at this, we have -3 and we have -3. So it means we multiply that by +1. And that's what is equal to 0. So we have 2x plus 1, 2x plus 1. And then we pick 1 from the brackets, that is x minus 3. And that's what equal to 0. So we have two possibilities. The product of these two numbers is 0. So it's either 2x plus 1 is equal to 0, so that 2x is equal to -1 and x is equal to -1 over 2, or x minus 3 is equal to 0, so that x is equal to 3. So those are the two values of x, that x is equal to -half or x is equal to +3. Okay, so let us move on to the next question. So the next question requires us to solve this equation, that is 2x is equal to 1. So let us write that. We have 2 power x is equal to 1. So here we're just going to apply the laws of indices. Remember that you can write 1 as any number raised to power 0. So it means therefore that we can write 1 to a 0 to a base of 2. That is, we can have 2 power x being equal to 2 power 0. So remember, this is the same as 1. So now if you observe both sides of this equation, you realize that the bases are the same, that is 2 is equal to 2. Therefore, the powers are also the same, so that x is equal to 0. So the solution to this equation is that x is equal to 0. Let us move on to the next question. So the next question says, a projectile is fired vertically into the air. The distance in meters above the ground as a function of time in seconds is given by s is equal to 300 minus 100t minus 16t squared. When will the projectile hit the ground? That is the question that we have to solve. So now, remember, the projectile will only hit the ground when s is 0. So it will have come back to the ground. So it means the projectile hits the ground when s is equal to 0. So we equate this equation to 0. So we can write this as minus 16t squared minus 100t plus 300 is equal to 0. So we can use it the way it is, or we can simplify it. But let us just use it the way it is. We can solve this as a quadratic equation for t. So we are going to use the formula for the quadratic formula. So we're going to say that t is going to be minus b plus or minus, under the root we have b squared minus 4ac, and that is all over 2a. So let us apply this formula. So we have to highlight what we have as a, in this case a, the coefficient of t squared, that is minus 16, and then we have b, which is minus 100, and then we have c, in this case c is 300. So all we need to do is just substitute these values into the formula. So we're going to have minus b. Remember, b is negative 100. So minus negative 100 plus or minus, and under the root sign we have b squared, that is minus 100 squared minus 4ac, and a is minus 16 and c is 300. Let us stretch that there. So this is over 2a. So a in this case is minus 16. So let us now simplify this particular expression. So we have minus minus, that will be plus. So we have positive 100 plus or minus, under the root we have 100 squared minus minus. So if you add or if you simplify what is under the bracket, you're going to have this as 100, that is 10,000. And then when you combine these other two, 4 times 16 times 300 is 19200. 19200, and that is over minus 32. So we have 100 plus or minus, under the root we have 29,200. 29,200, and that is over negative 32. So the square root of 20, the function under the radical, we're going to have that as 100 plus or minus. When you get the square root of these, it is the same as approximately 170.8800 something, and that is over negative 32. So we have two values. There is the plus and then there's the minus. So it means, therefore, that t can either be, when we take the positive, that is 100 plus 170.88 divided by negative 32. So that should give you negative 8.465, or you could have t, when we use the negative sign there, so 100 minus 170.88 over negative 32. So that should give you positive 2.215. And remember, t is time, and we cannot have negative time. Therefore, what this means is that t is equal to 2.2 seconds. Okay, so let us move on to the next question. And the next question requires us to, we have, if alpha and beta are the roots of the equation x squared plus 4x minus 12 is equal to 0, find the equation whose roots are alpha plus 1 and beta plus 1. So for us to be able to obtain the equation of this other line or this other function, we are going to need the values of alpha and beta so that we're able to substitute here. So the first thing is to obtain the sum and the product of roots of the equation that we have, that is x squared plus 4x minus 12 is equal to 0. So the sum will be alpha plus beta, and for us to obtain that, we use the formula minus b over a. So from this equation, we can highlight the values, and you see that a is equal to 1, b is equal to 4, and c is equal to minus 12. So we have minus b, and b is 4. So that is minus 4 over a, which is 1. So the sum of roots for this equation is minus 4. And then the product of roots, that is alpha beta, is given by c over a. And in our case, c is minus 12 and a is 1. So the product of roots will be minus 12. So now the next thing will be to look for the sum and product of roots of the required equation. So we're going to look for sum and product of roots of the required equation. So the sum of roots of the required equation, just take the two roots that you have here. The first root is alpha plus 1, and then you add it to the next, which is beta plus 1. So you have beta plus 1. So remember, you do not know the value of alpha, you do not know the value of beta, but you can obtain alpha plus beta and you can obtain alpha beta. So you manipulate this expression so that it fits what you have. So let us do that. So we're going to have, you can write this as alpha plus beta, then we have 1 plus 1, which is just plus 2. So look at this, you have alpha plus beta, and that is what you have here. So that is negative 4. So just substitute, you have negative 4 plus 2, which is just negative 2. So that is what we have as the sum of roots for the required equation. So we can use the same procedure to obtain the product of roots. The product of roots will be, just take the 2 and multiply them. That is alpha plus 1 times beta plus 1. So you can do this manually. You have alpha into beta plus 1 into beta plus 1. You open up that, you have alpha beta plus beta plus 1. So again, you do not have the value of alpha, nor do you have the value of beta, but you have the value of alpha beta as negative 12, and you have the value of alpha plus beta as negative 4. So all you need to do is just substitute for those values here. So alpha beta is negative 12, and alpha plus beta is negative 4, now plus 1. So that if you simplify, it should be negative 15. So now that you have the sum, and you also have the root. You have the sum and the product of the roots. You can now just obtain the equation of that, uh, the required equation. Sorry, and remember, the standard form of this required equation is given by x squared minus the sum of roots x plus the product of roots is equal to 0. So all you need to do is just write x squared minus sum of roots, and the sum of roots according to this is negative 2. So minus 2, that will be plus 2. Then you have x, and then plus the product, and the product of roots is negative 15. So minus 15 is equal to 0. And that is the equation that was required. So let us now move on to the next question. The next question requires us to describe the nature of the roots of this particular equation. So for us to be able to describe the nature, we need what we call the discriminant. The discriminant, and the discriminant is given by b squared minus 4ac, the value that appears under the root in a quadratic formula. So we want to look for the discriminant of this equation, and from this equation you can see that a is given by 2, b is given by, you have to rewrite this as 2x squared, then you bring that to the left, it becomes minus x 7x plus 4 is equal to 0, so that you can see a, b, and c clearly. So a is 2, b is negative 7, and c is 4, which is positive. So it means therefore that the discriminant, that is b squared minus 4ac, is going to be, our b is minus 7, so we have minus 7 squared minus 4ac. A is 2 and our c is 4. So that is the same as 49 minus 4 times 2 times 4, that is 32. So our discriminant is the same as 17. So when the discriminant is the same as 17, remember when the discriminant is greater than 0, 17 is greater than 0, 17 is obviously greater than 0. When the discriminant is greater than 0, then we say that the roots are real. That is the first description that we'll have. The roots are real. So we'll have the roots are real. Another thing that we'll observe is that they are irrational. They are irrational. And then the most important thing is that they are not equal. They are unequal, or you can say they are distinct. Distinct. That marks the end of that paper.